Welcome to the climate change presentation. We are Team 1, and today we would like to talk about radiation and the Earth energy balance, the elements of the climate, the measurement of climate change, statistics, significance and cycles, the natural causes of climate change, and human activities. Anytime you can stop the presentation and read the slides. First of all, we need to understand that the climate is extremely complex. Everything in the system is connected to everything else. We have to distinguish between weather and climate. Weather is what is happening to the atmosphere at any given time, like right now. And climate is what the statistics tell us should occur at any given time of the year. Statistics of the weather phenomena that provide evidence of longer-term changes. We need to understand the difference between climate variability and climate change. Climate variability means short-term fluctuations, while climate change means long-term fluctuations, shifts in meteorological conditions lasting a few years or longer. They may be a decline or increase of different conditions, temperature, rainfall, or some more general shifts in weather patterns to colder, wetter, cloudier, or windier conditions. Radiation and the Earth energy balance. All the energy that matters comes from the sun. The incoming flux is matched over time by the outgoing terrestrial energy. The basic laws of physics define this balance. Anything that has the potential to influence this balance, either in global terms or in respect of one part of the planet as opposed to another, could alter the climate.
The essential feature of the various elements of the Earth's climate is how they are all connected to one another. So we will consider how each element affects the others to establish what are the most important components of the climate. A. The amount of solar energy that is absorbed, in particular the importance of clouds, snow, and ice and land surface effects, including the role of the hydrological cycle and the biosphere. B. How energy is transported across the face of the Earth by both the atmosphere and the oceans. C. How the amount of energy radiated to space is controlled by various elements, again placing particular emphasis on the role of clouds. The timescale of response to changes in all these processes is also related to how they contribute to climate variability. For the most part, the atmosphere responds more rapidly to a variety of stimuli. In comparison, the oceans are effectively slower to respond, but can bring about much greater changes. The reaction rate of surface conditions lies somewhere between the atmosphere and the ocean. Changes can have lags and leads, causing elastic and sometimes contradictory responses throughout the system.
Chapter 4 describes the measurement of climate change. In order to observe climate change, it is necessary to measure various meteorological data. A common measurement method is to observe with an instrument in situ. Typical contents are temperatures, sea surface temperature, and rainfall. However, one thing to be aware of when handling these measurements is the effect of the measurement condition. Some use satellite to measure the data. Measurements include clouds, rainfall, polar snow, drift ice range, and vegetation height. Other methods of acquiring meteorological data include the use of historical records and the use of proxy data. Proxy data is used when there is no observation or historical records, and it is measured using tree rings, ice cone, ocean sediments. However, these data can be erroneous. With this With this in mind, it is important to use a wide range of accurate measurements and to use large amounts of data to correct errors in order to measure climate change. はい。
There are statistical methods that have been devised to reveal important changes and cycles in climate from noisy data. The basic nature of the data to be studied is that they are measured at the required frequency for the required period of time with small errors at equal intervals. はい。The time series data can be expressed as a sum of waves with different amplitudes by Fourier analysis. Fourier analysis can be easily performed by a computer, but the important thing is to interrupt the power spectrum obtained by the analysis. はい。But by obtaining the power spectrum, we can observe the characteristic cycles. The importance of such cycle can be strengthened by considering physical hypotheses about them. It is also necessary to take into account the various types of noise in the observed meteorological data. はい。The statistical significance of any weather series can be determined only when the shape of the distribution about the mean is known. Some of the parameters can be approximated by Gaussian distribution, but in many cases the distribution is different from a Gaussian. By accurately getting distribution, it is possible to give statistical significance. はい。Wavelet analysis express a function not by superposition of waves of trigonometric functions as in Fourier analysis, but by superposition of short wavelets. The advantage of using wavelet analysis is that it can analyze a wider frequency range than Fourier analysis. It is also possible to analyze time series data with non-stationarity. はい。For climate data, multivariate analysis can be used to model climate change and analyze the impact of human activity. Principal component analysis can reduce the number of variables without loss of essential information and can obtain important features of changes that make up a large part of the whole. However, it is important to understand the physical background of the principal components. By using these techniques, we can identify the physical drivers of climate change and even help make useful predictions of future changes. はい。
It is not easy to determine which effect is most important when considering climate change due to human activity. Two priorities emerge from this review. First issue is to get a better fix on the internal variability of the climate. Finding out about how the oceans and the atmosphere interact on timescales of centuries is central to deciding to what extent changes during the 20th century are the product of climatic autovariance as opposed to human activities. In addition, providing an explanation as to why the climate of the last 10 years has been relatively stable and whether this stability could be disturbed by natural causes or human activities is equally important. Second issue is to establish a balanced and more thorough understanding of how human activities can affect the climate. This is not just a matter of increasing levels of greenhouse gases, but also the direct and indirect effect of particulates and the changes in land use, including desertification and deforestation. These are subordinate issues, although a growing knowledge of how these factors alter the climate will assist in the primary objectives of understanding the impact of human activities. はい。
Human activity is considered to be one of the major factors of climate change. At the local level, there is no doubt that human activities are changing the climate. The impact of urbanization is so small as to be ignored. They do, however, give us an indication of what effect human activity will produce and an insight into what a warmer world might look like. はい。 Globally, the largest contributor to the greenhouse effect from human activity is CO2. CO2 has been closely monitored since 1958, and CO2 concentrations have increased from an average of 280 ppm before 1750 to 380 ppm in 205. Similarly, powerful greenhouse gases such as methane and nitrogen compounds are also increasing in the atmosphere and require international action. はい。 Reducing aerosol emissions into the atmosphere is more important than reducing global warming gas emissions. The direct impact is the effect of aerosols on the Earth's radiation budget, depending on the degree to which they absorb or scatter the sun's rays. Aerosols also have an indirect effect on climate by changing the formation, distribution, and characteristics of clouds, which in turn changes the cloud radiation budget and precipitation patterns. はい。 Desertification destroys the agriculture and livestock industries in the region, causing many people to starve to death and having a major impact on the global environment. In fact, more than 100,000 people have died of starvation due to the drought in the Sahel that began in earnest around 1970. In addition, more than 20 million hectares of formerly productive soil have been transformed into unproductive deserts. Desertification is a complex process, and climate change is thought to be a major factor. はい。 The cause of ozone hole was CFCs, which were used in industrial cleaning and cooling agents. Over Antarctica, oxygen was combined with ozone by sunlight, but the ozone was destroyed by conical bonds generated by decomposition by ultraviolet light. The Montreal Protocol of 1987 and its subsequent amendment eliminated certain CFCs from industrial production, resulting in a 40% reduction in the level of certain gases within 5 years.
Thank you very much for watching to our introduction to climate change. What do you think about it?